All right. Hello, I am DeWitt Weston, the Community Relations Associate here at Aljoya Thornton Place. Before we start today's presentation, I'd like to share a little bit about our beautiful community. Aljoya Thornton Place is a premier retirement community located in North Seattle, featuring spacious, elegant apartments, exquisite cuisine currently being delivered to our residents' apartment daily, and robust, meaningful life enrichment activities to keep our residents engaged, entertained, and connected. Additionally, our tranquil and well-maintained outdoor courtyard and the Thornton Creek walkway are perfect for visiting with friends and family during times of social distancing. If you are interested in learning more about our community, please contact our community relations team and we'll be happy to answer any questions or take you on a tour of our community on request. We can be reached at 206-306-7920. And now to our main event. We are honored to host Dr. Abby Winter, who will be presenting on Vaccines 101. Dr. Winter is a licensed pharmacist and a clinical assistant professor at University of Washington School of Pharmacy and serves as a director of outreach for the Plein Center for Geriatrics. Abby leads the educational, clinical, and outreach efforts for the UW School of Pharmacy at the Era Living Communities. Take it away, Abby.
Great, thank you very much. I'm going to get my presentation up here for you all to see. So as he said, we will be talking about vaccines today. Another quick highlight about who I am. I am also the pharmacist that works with all of the Era Living communities. I help with do patient consultations and work with the Wellness Center staff. And then I am the assistant director for outreach for the Plein Center, which works on geriatric pharmacy education, research, and outreach for the UW School of Pharmacy. So today we'll be talking about vaccines, specifically how they work, the history of some vaccine development, different types of vaccines. We'll do a quick overview of vaccine trials and talk about efficacy versus effectiveness, which we've probably all been hearing a lot about in the news these days. And then we'll do a quick overview of some of the vaccines that are recommended for older adults. So as we go through this today, we'll probably all be thinking about the COVID vaccines because that's what's been on our minds lately in the news around the world. But keep in mind that this is also applicable to most all vaccines that you may have received or will receive in the future. So first, let's talk about how vaccines work. And we need to first understand how the body fights infection and fights illness. So we look first, viruses or pathogens can enter the body and they attack and multiply within the body. And that's what causes the infection. And then we count on the body's immune system to fight that infection. So we'll look at some white blood cells. There are 3 different types of white blood cells, or what we'll call immune cells, that work together to fight infection. They do a bunch of different things, but some of their primary actions are that they digest the germs, any dead cells in the body that those germs have killed, any cells that are dying, and they leave behind what's called an antigen. The body then sees these antigens and sends antibodies to attack them. The body produces antibodies that will attack these antigens, and it's the immune system has to work its way up to build them. The immune system then attacks the cells in the body that have already been infected as well. So it's quite a complex ordeal, but the body is intelligent and works really well to fight off any infection that comes in. So another way to think of this is picture someone trying to rob a bank. So that germ or that pathogen that comes into the body is the robber, and the immune system is the bank. The security camera catches the robber entering the bank, and that sets off the alarm. So we can think of it as a white blood cell or one of those immune cells that is the security camera that sees the bad guy entering the body. The alarm then notifies the security guards, and they find and detain the robber. In the same way, the white blood cells tell the antibodies, and they come and find the pathogen. The bank then, because of this security breach, adds more security cameras. They hang up pictures of the robber, like this wanted sign, the same way that the body creates memory cells in order to remember the pathogen and how to get rid of it quickly if we see it again. So we'll talk a little bit more about those memory cells. So with the first encounter, it can take the body several days to build up a defense, but then it creates these memory cells so that with future encounters, the immune system remembers and knows how to fight and protect itself. So if the same pathogen presents again, those memory cells can respond really quickly. So let's think about this as if someone gets a natural or infection. If we're specifically thinking about COVID, someone becomes exposed to it and gets sick, it takes the body quite a while to fight that off if they've not seen it before, whether from being infected before or with a vaccine. And but if they were to see it again, then they can fight it off much more quickly. So we'll look a little bit deeper at vaccines. The way that vaccines generally work is we present the body with a weakened, inactivated, or a dead version of that pathogen or the germ. It imitates but does not cause an illness. We often call this an imitation infection. So it's not a true infection, it's just imitating it. And then once that occurs, the body develops a defense against it. So it's able to recognize and fight it in the future with those memory cells that we talked about. So our bodies develop immunity by imitating an infection. We need a supply of those memory cells that our immune system creates after they've been exposed to the vaccine so that they remember how to fight it in the future. And as we kind of have seen, it can take a few weeks for the body to produce memory cells after receiving a vaccine. So sometimes folks will think of the flu shot. They may get a flu shot, but still get the flu, or they might get it within a couple of weeks of getting that vaccine. It's not because the vaccine caused it. That's not actually something that can happen. It's because maybe they were exposed to the virus already, and that flu shot takes a couple of weeks to build up an immunity. So we need to remember that just the day you get the vaccine, it doesn't protect you immediately. Your body still has to go through all the steps and all the functions to build that immunity. So many people consider vaccines to be one of the greatest breakthroughs in modern medicine, and I would tend to agree. They help combat deadly illnesses, sometimes even eradicating them completely. But we're only able to reach the full potential of a vaccine if enough people in the world get vaccinated. Vaccines are generally safe, and often we only have minor side effects from them. So understanding vaccines a little bit more, we'll look at something called herd immunity. We've probably been hearing this more in the news lately, but herd immunity counts on a few things in order to provide protection for our community. We need people vaccinated from the disease, people who have recovered from previous illness, and that's for most pathogens, and then making sure that there's no human source for continued spread of the pathogen. So we need enough people that have developed protective antibodies against future infection, and the multiple ways that can happen are through vaccination or having had the illness already. Herd immunity then helps those who cannot be vaccinated. So some folks with weakened immune systems can't receive certain types of vaccines. Some children are too young to have been vaccinated against certain things, or vaccines aren't approved for kiddos of a certain age. And so if we can get herd immunity through natural infection or people getting vaccinated, it helps protect the more vulnerable folks in our communities. So we talked briefly about eradication and how vaccines are really great at preventing serious illnesses, but in some cases, if we do enough as a society, we can eradicate it. So currently, the only disease that is technically been eradicated from the world is smallpox. And just a quick note here, the smallpox vaccine was first developed over 225 years ago, but it took until 1980 for the WHO, the World Health Organization, to declare it eradicated. So it's quite an intense effort and a long effort, but it is possible. polio is considered extremely close to eradication. It has been considered eradicated in the United States, but not around the world. And as long as travel between countries continues, that eradication can't really be considered across the world, but it is eradicated in the United States. And then things that are considered, quote, nearly eradicated are diphtheria, bacterial influenza, measles, mumps, rubella, tetanus, and pertussis. So we're very close, but as we've seen in the news lately, or in the last few years, there have been measles outbreaks or mumps outbreaks from folks who have not received those vaccines. So it reminds us that it's increasingly important that we continue to vaccinate for these things that we don't consider to be current issues, because they can spread quickly if we give the virus or these pathogens just a few vectors to be able to spread. So now we'll jump into the history of vaccine development. I'm not going to go through every one of these, but it does give you an idea of all the vaccines that are currently available, dating back to the 1700s or 1800s. First, we need to understand how infectious diseases how long they have been around. So back in the 1500s is when we first saw the smallpox epidemic in India. We also saw a whooping cough, which is pertussis epidemic in Paris. And in the 1600s, that's where we saw the earliest case of typhoid fever on record, and Spanish diphtheria and early smallpox came to North America. So back in the 15 and 1600s, we started seeing infectious diseases, but we didn't have any way to prevent them. Until there are some reports as early as 200 BC that there were sources that claimed an inoculation type practices from Buddhist monks who would drink snake venom to try to provide immunity from snake bites, which gives us an early taste of what vaccines might have looked like. But the process became a little more sophisticated, we'll say. There was a Chinese emperor who survived smallpox as a child, and then because of that had his children inoculated. And the way that he did that was grinding up smallpox scabs and blowing them into nostrils of those that wanted to be inoculated. Or they would take matter from smallpox sores and scratch it into the skin. I, for one, am very grateful that vaccines have become much more sophisticated since then. There were other reports of what they called an operation, which is not really what it was, but they would place a little bit of smallpox matter on the head of a needle and inject it into a vein. But the first time that we truly started calling this a real type of vaccine, essentially, was in 1774. There was a farmer who inoculated his family with cowpox. So it wasn't smallpox, it was cowpox, but they're very closely related. And then the family members who became inoculated with that cowpox virus were then protected from smallpox. So that was essentially our first taste of the more sophisticated type of vaccine that we see these days. And where does that word vaccine come from? We're going back to that farmer who used the cowpox vaccine because it contains the vaccinovirus. So we use the name of that virus to coin the term vaccine. So a long history there, back to the 1700s, and we've come a long ways to now developing vaccines like the COVID vaccine in much more scientific and sophisticated ways. Let's jump into different types of vaccines. There are many of them. We've been exposed to some newer ones lately in the news, but we'll talk today about live attenuated, inactivated vaccines, toxoid vaccines, recombinant polysaccharide and conjugate vaccines, the DNA and RNA ones that we've become more familiar with, and viral vector vaccines. So first is live attenuated. So even though it says live, which can be a little concerning for some people thinking that this vaccine is live, has a live virus in it, it only contains a weakened version of that living virus or bacteria. And it does not cause serious illness or serious disease in people who have healthy immune systems. These live attenuated vaccines are really good teachers for the immune system, and it's the closest thing we have to natural infection. And remember, we need that imitation infection or that natural infection to show our bodies what this illness looks like, so they can say, okay, let me figure out how to fight it. So then if I see it again, I'll know how to fight it really quickly. And so we want something that's a really good teacher and close to natural infection. And these live attenuated vaccines do just that. Some examples are the MMR vaccine, which is measles, mumps, and rubella, which we all probably received when we were youngsters. The varicella vaccine or chickenpox, yellow fever vaccine, rotavirus, which is another one for kiddos, and then the quote unquote old shingles vaccine, which we have a new one that's come out that is not a live vaccine. Next is our inactivated vaccines. So these contain inactivated or a dead form of the pathogen, which produces a different type of immune response than those live vaccines do. And often they can require multiple doses to help build or maintain immunity. But some examples are the inactivated polio vaccine or IPV, the rabies vaccine, and hepatitis A. Next is toxoid vaccines. So these are a little bit different, a little more complex. They help prevent diseases that are caused by bacteria that produce what are called toxins in the body. So these vaccines create immunity to a part of that pathogen or germ that caused the disease rather than the pathogen itself. So just a part of that pathogen. So they're a little bit more focused in how they work. They contain a weakened toxin, which is called a toxoid, but they cannot cause illness. So when the body is exposed to a toxoid, the immune system learns to fight off that natural toxin. So one example is the Tdap or Tdap vaccine, which is diphtheria or tetanus toxoid. The next one you will talk about is the recombinant polysaccharide and conjugate vaccine. So they're three different types, but they work kind of similarly. So first thing to realize is that these then just use pieces of the pathogen. So not the entire virus, but maybe it's protein or a sugar portion or a casing of the virus in order to fight off illness. So this vaccine targets just that key part of the germ, but because it's so targeted and focused, it results in a really strong immune response. These are safe for people with weakened immune systems, but often we need booster shots to get that protection to continue to be ongoing. So some examples of these are HIB, which is a type of the influenza virus, hepatitis B, HPV, which is the human papillomavirus, whooping cough, which is has pertussis, which is the P in the Tdap, pneumococcal disease and meningococcal disease, and the new shingles vaccine all work this way. Next, we'll talk about our DNA and RNA vaccine. So we've all probably become cursory experts in these days, but this technology is decades old. They've been working on it for at least 10 to 20 years, but the vaccines themselves are more newer developments. So these vaccines make proteins that then trigger an immune response. It provides the cells in the body with instructions for how to make what's called an antigen, which can then fight off infection. And the good thing about these mRNA vaccines is they have a much shorter manufacturing time, as we've obviously seen lately. They also have no risk of causing disease, which is really wonderful and consistent with other vaccines. And currently, the only example of this is a couple of the COVID-19 vaccines that exist. And then lastly, the viral vector vaccines. So these use a modified version of the virus, of a different virus to deliver protection as via a vector. So this other virus will come into the body to help serve as a vector of the one that we're trying to fight off. So different viruses that we can use are the influenza virus, the VSV virus, measles virus, or adenovirus. Something to consider with these, though, is there's a possibility that it can be a little bit less effective for some folks if they've already been exposed to the virus that's being used as a vector. But scientists have been studying this type of vaccine for decades as well, and they can be quite effective. The couple of examples, first, there's a COVID-19 vaccine that is a viral vector vaccine, and we're using this technology to study things like Ebola, Zika, HIV, and different types of flu vaccines. So now let's talk a little bit about vaccine trials. So we know these all exist. How did they come about? How do I know that these vaccines are safe? First, we'll talk about safety testing. So vaccines are held to incredibly high safety standards, which we would all hope because they're being injected into our bodies. But there's testing done before they're approved and ongoing testing and observation after they're approved. So before they're approved, the testing includes lab testing, which often takes years, and then they determine if it's okay to test it with people. So with vaccine development, there's many stages. We start with exploratory stage, then a preclinical stage, clinical development, regulatory review and approval, and then there's manufacturing quality control that continues as long as the vaccine is being used. So with our clinical trials, these help evaluate safety and effectiveness with human volunteers. So it answers the questions, is this vaccine safe? What dose is best? How does the immune system react to this vaccine? So we have 4 different phases of our clinical trials with vaccines. The first phase, or phase 1, is with just a small group of healthy people. And with that, we see even just 20 up to 100 people, and we test this vaccine to see if it is safe in healthy people. If it's proven to be safe, we will move on to phase 2, which expands this patient population into those who represent what we'll call the intended audience, or someone who has the actual condition we're trying to fight, or someone who is of higher risk for the disease we're trying to vaccinate against. With phase 3, we expanded even further into thousands of people, and this is where they start to test for the efficacy and continue to test for safety. With most vaccines, 98 to 99% of side effects show up within the first 8 weeks or the first 2 months. So once these vaccines have been in patients for that long, we've most likely seen almost every side effect we're likely to see. There's a very low risk for a side effect to show up months or years down the road. So by the time we get to phase 3 and have expanded this to thousands of people, it's quite likely we've seen most of the side effects that will occur already. And then phase 4 is when we continue to have ongoing studies after a vaccine's been approved or licensed. Now we'll talk about vaccine testing. And so once it's approved or authorized or licensed to be used, the testing does not stop, which should make us all feel much better about receiving vaccines. So each batch of vaccine is tested for potency, which tells us, does it work like it's supposed to? Purity, which ensures that there are certain ingredients that they use during production that are removed. So is it pure? Does it contain just what it's supposed to contain? And then sterility, so sterile is that key word there. That ensures that there are no additional outside germs or anything present that's not supposed to be in it. The FDA also tests the factories where these vaccines are made, and they have different quality and safety standards that they have to meet and maintain. So side effect tracking, I alluded to this a little bit earlier, saying that most side effects that are consistent with vaccines do show up within the first 2 months. But just in case there is extra safety standards in place, and the biggest thing, you may have heard of this called the Vaccine Adverse Event Reporting System, or VAERS is what people will refer to it as. VAERS is the acronym. It is a national vaccine safety surveillance program that's co-sponsored by the FDA, which is the Food and Drug Administration, and the CDC, the Centers for Disease Control and Prevention. And what it does is collect and analyze information from adverse event reports. So this is an awesome thing, but there are a few limitations of it. Who can report to this? Patients, providers, parents, pharmacists, vaccine manufacturers. Anyone has access to VAERS, which is both good and possibly bad. It's good because anyone can say, I've had a side effect, and report it so that we have a vast amount of information to go off of. However, if anyone can report a side effect, there may be side effects that are not linked to the vaccine, may or may not be truthful, that get reported to this system. And if enough of that gets reported, it flags the system, and then folks look into potentially pausing manufacturing the vaccine or pausing use of the vaccine when a side effect may or may not actually be linked to it. However, if there are side effects that are quite rare or only a few people are experiencing them, but those get reported, it's great because we have that information and then we can do more studies and more tests to determine if it's actually linked to the vaccine and if we do need to stop vaccine use to help keep patients safe. Now let's move on to efficacy and effectiveness of vaccines. You may have heard these terms quite a bit lately, and they are not interchangeable. There are differences between them. Efficacy is the percent reduction in disease incidence, so how often it occurs, in a group of vaccinated people compared to a group of unvaccinated people. So the biggest thing to consider with efficacy is that it must be under ideal and controlled conditions. So this is in a lab, okay? We're gonna look at these ideal conditions. So optimal conditions means patients who have no other chronic conditions. So they don't have high blood pressure, they don't have high cholesterol, they don't have diabetes, they don't have heart disease. They got all of their doses exactly on time and they did not miss a dose. So if it said to get another dose in 14 days, they were there on the 14th day, no matter what. They have no other medications that they're on. So they're not on a high blood pressure medicine. They don't take Advil regularly, things like that. Their side effects are monitored very closely. So maybe they're filling out a journal every day and thinking about the side effects or how their body feels. They're reporting to someone in the trial every day or every week any possible side effects that they have. And often it does not include what we'll call age extreme. So we don't include the very young or older adults who are often commonly recipients of vaccines. So these optimal conditions look at kind of this perfect or ideal situation to say, how well does this vaccine work? Effectiveness is another term that we'll talk about that is similar but different. Effectiveness looks at the ability of a vaccine to prevent the outcomes of interest, so getting a disease or serious illness or hospitalization or death from it. But it looks at the ability to prevent those outcomes in the real world. So this is done by looking in observational studies. So what does the real world mean? There are so many different things that can affect the or impact effectiveness in the real world. So for a patient, factors to consider are age, other chronic conditions, prior exposure to an illness, and the time since they've been vaccinated. So we can't control for these things as much out in the real world, right? Once it starts in the real world, we have those age extremes, the younger and the older who are getting the vaccine. We have folks who have other chronic conditions because most people do. There are also people who may have been exposed to an illness in the past, which can impact how well your body fights off infection with or without a vaccine. The vaccine itself has a few factors as well, like how it's delivered in the body. Some are injected what we'll call sub-Q, which is under the skin into the fat. Some are into the muscle. There are oral vaccines. Those all impact how well it works because different people's bodies will absorb or process that vaccine differently depending on how it's introduced. The type of vaccine as well plays a huge role. So we talked about all those types, a live vaccine and inactivated vaccine, the toxoid vaccines, those all work differently. And then what the vaccine is made of also impacts how well it works out in the real world. Other things such as, does the vaccine, quote unquote, match the strains or the variants that are circulating? So a couple of examples there. With the flu shot, you may be aware that every year the flu shot has different strains. They look at what flu hit in the winter in the other hemisphere to say what one's most likely to come to us in the United States. And then we develop a vaccine that tries to match the 3 or 4 most common strains that are circulating. And so if we do a really good job and the flu strains don't bring in other strains that we're not ready for, if we do a really good job at matching it, that vaccine is going to be have incredible efficacy and be really effective. But if the matching doesn't work well, or there's a strain or a variant that comes in that we weren't expecting and it hits hard, one example of that was the H1N1. When that hit, we didn't quite have the vaccine with that strain in our initial flu shots. So it didn't do as good of a job out in the real world. But that was also when then they created the H1N1 booster vaccine that everyone could get to help protect them against that additional strain. Or if we think about variants circulating, we're talking a lot these days about the Delta variant of COVID, and whether or not our vaccines are fighting off that Delta variant effectively. Which we are seeing great data about, which is reassuring for sure. But again, it just shows another thing that even though these vaccines could be really awesome in the lab and really awesome when we look at them under ideal conditions, we get out into the real world and a lot of different things can impact that. A couple of notes here. No vaccine is 100% effective. Some food for thought though. The FDA set only a 50% efficacy cutoff to get emergency use authorization for these COVID-19 vaccines. 50% was all we wanted because we know that that's really great at preventing death, saving lives. So the quote that they had from the FDA was that they wanted it to be able to prevent disease or decrease severity in at least 50% of people who are vaccinated. And doing that, we knew would have a huge impact on the world. And as you may be aware, most of our COVID vaccines had over 90%, 95, 98% efficacy when they were first developed. We then have other factors that come into play that changes out in the real world. But keeping in mind that 50% was something we were going to be really jazzed about, and we got much higher than that. Another thing to keep in mind, the flu vaccine efficacy varies from year to year. As we mentioned, there are different variants or strains of the flu that we're trying to target. And so we see efficacy rates anywhere from 40 to 60%, which now we might see that and say, man, that's pretty low because I've seen these other vaccines with upwards of 90% efficacy. But even with a 50% efficacy rate, the flu shot saves thousands of lives every year. So just because we're not seeing 90, 95% like we might be used to now, does not mean that these vaccines aren't working. They are working and they are helping to save lives. Now let's talk about the different vaccines that are recommended for older adults. I'm going to talk about 5 in particular today, but it's really important that you would talk to your healthcare provider, your pharmacist, your primary care doctor about any other vaccines that may be warranted for you based on your health conditions or other factors that can come into play. But with older adults in general, it's important to remember that as we age, our immune systems do weaken over time. And this can make it a lot more difficult to combat different infections and illnesses. It also can increase your susceptibility to have complications from these diseases that are often preventable. And what vaccines can do, as we mentioned earlier, is help teach our immune system how to fight off the infection. So even if your immune system weakens over time, having the appropriate vaccines introduces your body or gives them the instructions for how to fight, so that if that illness comes into your body, your immune system doesn't have to spend time reading the book, learning the material, developing a plan before it fights. It gets introduced to the illness and it says, oh, let me go into my Rolodex, figure out how to fight that. There's that plan and it starts to attack right away. So essentially vaccines are kind of like having the blueprints for the fight ready to go instead of having to create it every time that the virus or pathogen comes into the body. So first we'll talk about shingles vaccine. The shingles vaccine or the Shingrix vaccine helps to fight shingles, which is a really painful skin rash. It's caused by the virus that's responsible for chickenpox. So if you've had chickenpox in the past, you are at risk for developing shingles. So who should receive this vaccine? All adults 50 and older are recommended. It is recommended that they get the shingles vaccine. there's no maximum age for the shingles vaccine either. There are sometimes indications for folks under 50 to receive it if they have weakened immune systems or that sort of a thing. But in general, 50 and older, everyone should get it. It is a 2-dose vaccine. It's separated by 2 to 6 months. So you get your first dose and 2 months later, you get your second one. You can wait up to 6 months to get it as well, and it will still be effective. And it has a greater than 90% effective efficacy rate. The old shingles vaccine was not as effective and worked a little bit differently. And even if you got the old vaccine, it is recommended that you get the new one, which came out just a few years ago. Next, we'll talk about the pneumonia vaccine. So there are 2 different pneumonia vaccines. The first is Pneumovax 23, and the other one is Prevnar 13. So they both will help prevent pneumococcal disease. So pneumococcal disease can cause severe infections in your bloodstream and your organs. We often think of pneumonia in the lungs, but pneumococcal disease can spread to other areas as well. Any adult 65 and older should receive a pneumococcal vaccine. And some adults ages 19 to 64 may be indicated for it if they have other conditions, health conditions, or if they're a smoker, that can put them at higher risk for severe disease. So we do want them to receive a pneumonia vaccine. The 2 different pneumonia vaccines are intended for different populations and different ages. So it's important to talk to your doctor or pharmacist about which vaccine is appropriate for you. Next is influenza or flu shots. So flu shot season is upon us, believe it or not. Pharmacies have already started receiving the vaccine shipments and they are ready to go in most cases. But usually we recommend about mid-September to October is a good time to get it in the Pacific Northwest. We try to time it based on when flu season hits hardest so that the vaccine has time to build up and is ready to fight, but also hasn't weaned in efficacy by the time the majority of cases tend to appear. So influenza or vaccine or the flu shot helps protect against influenza, of course, or we'll call it the flu. So remember, the flu, sometimes if you got a stomach bug, you'll say you have the flu or the stomach flu. That's not the influenza we're talking about, though. The flu or influenza we're talking about is a viral infection of the lungs, nose, and throat. It can be deadly, especially for our high-risk individuals. So the very young or the older adults are at higher risk, or people with certain immune altering conditions. So who should get the flu shot? Everyone 6 months of age and older. And we need to get a flu shot every year. It's a seasonal vaccine because, as I alluded to before, the strain of the flu that hits each year can be different. And the flu vaccine itself does change every year to try to best match the strains that we're seeing circulating around. One other thing about the flu shot, in older adults, there is a high dose flu vaccine, which just helps you mount a little bit of a stronger immune response. So if you're 65 and older, that's often the one that is recommended. Most of the time, that's what the pharmacy will give you if you walk in. And that's the one that Era Living offers at their flu clinics as well. But always a good idea to advocate for yourself and make sure that you're getting the high dose if it is indicated for you. Next, we'll talk about our tetanus, diphtheria, and pertussis vaccine, or Tdap. You can see other variations of this like Dtap or TD. Those are often for our younger folks, but Tdap vaccine is what we'll see for most adults and older adults. So tetanus, diphtheria, and pertussis are all serious illnesses that can be prevented by vaccine. Diphtheria and pertussis can spread super easily from person to person. But tetanus is one that you might be familiar with. It can enter the body through different cuts or wounds. So often if you step on a nail, you want to get a tetanus shot. Or if you get a cut or a wound, it's a good idea to get a tetanus booster. So all adults should receive this vaccine. And then booster shots are recommended every 10 years. Or if you get a serious cut or wound, you'll want to get one. And sometimes, often it's recommended if you plan on being around a newborn baby, you want folks around them to get a Tdap booster. But I would talk to the parents or the pediatrician who's taking care of the child to see if that's recommended. But it helps, that gives us, takes us back to what we were talking about earlier with herd immunity. That's why it's important for folks around our newborns to get the Tdap vaccine, because if they are protected from the disease, it helps protect the youngsters as well, who either haven't gotten the full series of the vaccine or can't get the vaccine yet, or are more susceptible to complications if they were to encounter. The big one we're concerned about with the kiddos is pertussis, which is the P in the Tdap. And then lastly is our COVID-19 vaccine. So obviously we've all seen this a lot lately. So that COVID-19 vaccine protects against SARS-CoV-2, which is an infectious disease that's caused by our newly discovered coronavirus. It causes a respiratory illness that can spread from person to person through our respiratory droplets. So who should receive this vaccine? All people ages 12 and up. That's who it's indicated for currently. The good thing is there are very few contraindications, meaning there are very few people who truly should not receive it. For the most part, it's generally safe for all populations, including those with compromised immune systems. And you may have seen recently that the bodies that oversee our pregnant and lactating or breastfeeding women has also been recommended that they receive it as well. So again, very few contraindications, but important to talk to your doctor to make sure that it's okay for you. But as I mentioned, it is okay for most people with underlying medical conditions. In fact, it is perhaps even strongly encouraged for those because they may be more likely to have complications or serious illnesses if they were to get COVID-19. And as I think it was just today, it was released that there may be booster shots recommended in the very near future. We're starting to see, especially in certain populations after 8 months, the vaccine may not be as strong as we would want it to be. It is still helping prevent hospitalization and death after 8 months, but is less effective at preventing you from just getting the illness. So we're hoping to see the FDA approve this. It has not been approved for that indication yet, but we're likely to see that towards the end of September, there will be booster shots recommended for folks 8 months after they have been vaccinated. So that booster shot is different than the third dose that we're seeing recommended for folks with immunocompromising conditions or who are on immunosuppressive medications. That I like to think of these differently. That's a third dose that will help them get the appropriate response that someone with a quote unquote normal immune system got after 2 doses. But the booster shot is going to be recommended 8 months later to make sure that the efficacy of the vaccine hasn't waned. All right, so we went through a lot of information. I do want to note down here at the bottom, there are some great resources. The US Department of Health and Human Services has some great information about immunizations. The CDC has a Center for Scientific Education and Professional Development. The FDA has a site about vaccines, and the World Health Organization as well. And then I also use this source, the history of vaccines, to talk a little bit more about some of that stuff that we talked about earlier. But if you have questions, those are some great resources to provide you information about vaccines that you yourself can read or share with others who may have questions or be concerned about vaccines that they may be receiving. And with that, I am happy to entertain any questions that folks may have. You can feel free to type them into the chat or unmute yourself or show your video, and I'll do my best to answer any questions that you might have. But thank you so much for your attention and for attending today.
Thank you, Abby. That was fantastic. Does anyone have any questions that Abby can answer for you at this time? Well, it doesn't appear that we do have any questions. Thank you for that very, very thorough explanation. I think we all learned a lot today, and we are really grateful for your time today. So with that, I will wish everyone a wonderful afternoon, and we'll look forward to seeing you again on a presentation in the future. Oh, wait a second.
Actually, I do see a question that just came in.
Looks like one did come up. We'll go ahead and let you take that, Abby.
Okay. So first, it says, there is some concern about the possibility of future problems. Absolutely. There's definitely concern about that. And there's a lot of information circulating that raises concern for folks. I don't want to say that that's not warranted, because we know these, especially with these newer vaccines, they haven't been around for very long. And so it's right that people might be concerned. However, as I mentioned before, with every vaccine that has come out, as a 99, I believe it's 99, but I'm going to say 98 to play it safe, 98% of side effects that would occur or would come about happen within the first 8 weeks. So as the experts have shown us, if a vaccine has been around for 8 weeks and folks have had it for those 2 months, and it's been in those trials and those studies, it is incredibly unlikely that we will see new side effects show up after those 2 months. So that's another reason why those trials, they start small and then they expand. So after it's been given to thousands of people, or in this case, I think we're probably talking about the COVID vaccine, millions in the country, billions worldwide, and we haven't seen after 2 months and any new side effects showing up, it is incredibly unlikely that they're going to show up in 3 months or a year or 10 years. Because of the way that the vaccine works, your body's doing most of that work initially after receiving the vaccine. And then all it does is it tucks that plan away in the back of it. Like it's in the Rolodex, it's in the memory bank, so that if you get exposed to the pathogen, it just recalls what you already built up and remembered and then starts to fight. So after that initial time of creating that plan, your body's not really doing much else. That vaccine's not really having too much impact. And so vaccines have for years been considered generally safe. Mild side effects would be the concern. And as we said, the majority of side effects will occur in those first 2 months. And since those vaccines have already been around for longer than that, it is safe to say that we're unlikely to see things down the road. So I am not the end all be all, the expert in this, but I rely on those who are the experts and have been studying this for years and spent billions of dollars in their whole life and so much time studying it to give those recommendations. And they have said the same thing, that in the first 2 months is when we'll see the majority of them. So I completely understand having that concern of future problems, but I can also say with confidence that it's incredibly unlikely. The next question, why do some vaccines need a booster every year and others need it every 10 years for life? Great question. So the one that we think of every year is that flu shot, right? So the flu shot is trying to match the different strains. So the flu virus itself is quite complex, and there's many different, we'll say, types of flu virus that are out there. Each year, there are some that are stronger or more prevalent than others. So we try to match that flu shot to the vaccine, or in fact, to the virus that's most present. So if you've got, 10 different possible flu viruses going around, I want to know which one's most likely to impact me, and I want to be able to fight that one. If you get one of the different strains, if you get sick with one of the different strains of the flu, that doesn't mean you're not going to be able to fight it off. You still have an immune system, and the flu shot will help you fight that off, and it's likely to be less severe. But the ones that we get every year, most of the time we're talking about the flu shot, is in order to match which one is circulating, because there are different strains that can be the stronger ones every year. As far as those that need a booster every 10 years, that is most likely with our Tdap, because the vaccine can become a little bit less effective over time. Mostly that's because of the type of vaccine it is. So we talked about all those different types. There's some that do just tend to become a little bit less effective over time. And that's why those studies show us that in 10 years, you'll need another one. So that's different than seeing those side effects. That's just us doing our normal assessment of these vaccines over time to say, is it still working? And that's when we realize, oh, at 10 years, it might not be as effective. Let's give booster shots. Kind of like we're seeing with COVID, where at 8 months, it might not be as effective. That's why we want to get a booster shot. That doesn't necessarily mean we're going to need one every 8 months, but that will help us continue to keep that strength up. But that is changing every day, we're seeing with COVID. But I can speak to the flu with every year and like Tdap with every 10 years, just to give your body a reminder or give you another page to put in the memory bank so you're ready to fight off disease if you need to. Someone has, this I think was just an addition to the previous question about concern about future problems like possible cancers many years in the future. And again, the way these vaccines work and their ingredients and that type of thing are not as likely to cause those things years in the future. We don't really have, it's different than with drugs or medications, but vaccines also go through a different process than drugs or medications do. So with side effects and things like that, and the way that we know that vaccine is having the biggest impact early on in order to show your body what it needs to do initially, it's not continuing to have too much of an impact. It's put into the memory banks essentially. Another question here, are all flu viruses known or are novel ones still appearing? I am not really an expert to be able to speak directly to that. There are different strains that come about, and new ones are always possible as we're seeing there are different variants. Just the way that viruses work, they can replicate, they can mutate and create new variants or new strains. So it is possible that new things come about, kind of like H1N1, but that's why it's important that we've got those experts studying the flu every year and coming up with which variants or strains we need to fight against, which is another reason it's important to get that flu shot every year to make sure you're fighting the appropriate ones. We do see that the flu shot protection lasts longer than a year, but it's going to protect. So say you get a flu shot last year and it protects against strains A, B, and C. But then this year, strain D, E, and F are our most prevalent ones. You still have protection from A, B, and C for longer than a year, but we need protection against D, E, and F because they're the ones most likely to cause disease this year. So some of it is matching it to already existing flu strains, and some of it is matching it to new ones that have come about. Thank you guys for your questions. I hope those that I was able to answer them appropriately. And if not, feel free, you can email off to ERA and they will forward those questions to me. And I'm happy to get back to you with answers or resources for you to check out. Question here, how many years will it take for COVID to become a common disease? I am not an immunologist or an epidemiologist, so I am not really the one to touch on that, but I can direct you to some other experts who may be able to touch on this a little bit more. Make sure that if you're researching this information, you're using trusted resources like the CDC, the FDA, the World Health Organization, the US Department of Health, that sort of a thing, might be the best resources for that. Additionally, I know there are a lot of researchers at the University of Washington that are doing a lot of great work. So if you can find sources where they are quoted, that's often another trustworthy source as well. I'm sorry that I can't directly answer that question, but I do appreciate that you guys are providing awesome questions and thinking about this stuff. It's really great to see. So thank you for your participation.
Okay. As we have no more questions, thank you again, Abby,
of course,
for a very incredibly informative presentation today. I know we all learned something new. We will be emailing everyone an evaluation form, and we would love to hear your feedback on this presentation, as well as suggestions that may help future Zoom presentations. If you have any questions about Aljoya Thornton Place or would like a tour, please call us at 206-306-7920. Again, I am DeWitt Wesson, the Community Relations Associate here at Aljoya Thornton Place, and this concludes today's presentation. Hope everyone has a wonderful rest of their day, And we look forward to seeing you again for future Zoom events or until we meet again in person. All right. Thank you, everyone. Thank you, Abby.
Thank you.
Okay. Bye.